Any questions? Anyway, if you're looking at number 33, you want to solve for, in this case, x. We had talked about this initially, but with this one here, you're going to want to multiply across by t, right, like we had discussed. And then you're going to want to multiply across by e to the x. So this becomes e to the 2x minus 1 is 5t e to the x. Okay, are you with me so far on this? I'm just trying to judge roughly where everyone is at when I give you my answers. Okay, so bring everything to one side. So this ends up being a quadratic. You get e to the x squared minus 5t, e to the x minus 1 is 0. Okay, thank you. So the idea here is if you're solving this one, you're looking to solve this. This looks just like a quadratic. So, I could let s equal e to the x. And this just becomes s squared minus 5t. S minus 1 is 0. So you can solve this just like a quadratic equation. Right, because this is in the form of a quadratic. You've got, right, e to the 2x is just e to the x squared minus 5t e to the x minus 1. I let s equal e to the x. And now you got yourself a quadratic. It's got this ugly t in there, but it really doesn't matter. If you go through your quadratic equation, it's going to be s equals, in this case, 5t plus or minus the square root of b squared is 25t squared minus 4ac, the whole thing over 2 times a. So this becomes s is 5t plus or minus the square root of 25t squared plus 4 over 2. So there, that gets you to there. Now, I'm looking to solve for x, not s. So that means that what that means here is e to the x is 5t plus or minus the square root of 25t squared plus 4 over 2. And then you take the ln of both sides here. That by taking the ln of both sides, the x drops down. You get x is the ln of 5t plus or minus 25t squared plus 4 over 2. And that's it for this one. Oops, sorry. Erased it. Okay, so there's 33. Whoever is asking for 33. Okay, moving on, there was 35 as well. Yeah, there's not much more you can do. Yeah, there's not much more you can do there. Even subtracting, you don't really know, based on the t-value, you're not sure whether it'll be positive or negative, so you just leave it like this. And I'm sure that that's what the textbook did, left it in that form. But yeah, good question. Okay, for 35, it's the same sort of thing. You've got e to the x plus e to the negative x over e to the x minus e to the negative x is equal to t. Yeah, to t. So same deal here. What I would do with this one is get rid of the denominator. So this would be e to the x plus e to the negative x. Multiply across. That should make sense. Right? Multiply across, and then multiply across by e to the x. So you do the same trick. I get e to the 2x plus 1 is t times e to the 2x minus 1. And that's just me multiplying across by that value. Is this all right so far? Who's ever asking this one? I think it was Lan was asking. So now I'm looking to solve for x, so bring everything to one side. Yeah, is this good? Are you getting this? Good so far? All right. Divide it out. Okay, very good. So I'm not sure where, like I said, there's a huge lag on my screen, so I don't know where, like, what you're seeing versus what I'm typing, how long it takes to, like, transfer over. But I've now got e to the 2x equals t plus 1 over t minus 1. So same trick, you want to solve for x, take the ln of both sides. You get 2x is the ln of t plus 1 over t minus 1, and then just solve for x. So this is the ln. I mean, if you go to solve for x here, divide by 2, you get 1/2 the ln of t plus 1 over t minus 1. And we're done. Isn't it a 2? Isn't it a 2? Yeah, but when you divide out, it's a 2x, but then you have to divide by 2. So it becomes a half. I got the negative t minus 1 by distributing. If you distribute this into the brackets, you get t e to the 2t minus t. So then I brought that to the other side, and then I brought the 1 to this side. So you get negative t, that becomes a minus 1, negative t minus 1. Okay. So that's 35. I can take a look at 36 as well. How did I get line 2? Are you referring to, like, you'll have to respond, like right here, Yusria? Line 2. I multiplied across by the bottom. Multiplied across by this, it goes right here. That's all. Okay, so there's 35, and then Leanne wanted 36. Do you need 36? Do you need 36, Leanne? That line there, I just multiplied across by e to the x. So if you multiply across by e to the x, it becomes e to the 2x. E to the x times e to the negative x is 1. Right here. Yeah, if I multiply across by e to the x, that's all I did here. When that distributes in, e to the x times e to the x is e to the 2x. E to the x times e to the negative x is 1. Sure, Tareem. For sure. If you guys could respond, like, when there's an issue so that I can take care of it. Like I said, it's hard for me to judge because there's always a little bit of lag on my screen, so I don't know, like, at what speed you're getting my responses at. So the more you type, the easier it is for me to keep track of where we're at. I did do it to the other side, Yusria. I passed it into the value here. Let's take a look at 36, because it's exactly the same as 35. And then, like, it's literally the exact same steps. Like 35 and 36 are the exact same steps. So I can just do 36, and then you can follow along with me, and we'll do all the same steps. Like, it's literally the exact same steps, except for you change the 5 to the e to a 5. Oh, I guess there's a minus instead of a plus, but really not much different. So let's look at 36, and then I can go back and look at 35 as well, like Tareem, if you want me to. Yeah, I snuck it in the brackets. Sorry, Yusri, I should have mentioned that. That's hard. That was hard to follow. Good though. Okay, so for 36 here, so Tareem, kind of follow along with us in 36 and let me know if there's any issues. And then, like, I can jump back and look at 35 as well. Yeah, Reem, I got this written down for you. I'll take a look at it. Okay, so for 36 here, first thing you want to do is get rid of the denominator. So exactly as I did in 35, I'm going to multiply across by the denominator, giving us 5 to the x plus 5 to the negative x. Yep. Right, so in 36 here, I just multiplied across by the denominator. So 5 to the x plus 5 to the negative x. And now we do the exact same trick as I did last time. I'm going to now multiply across by 5 to the x. So this becomes 5 to the 2x minus 1. Again, I'll just pass that 5 to the x into the brackets because that's where I want it to go. And you end up getting 5 to the 2x minus 1 equals t times 5 to the 2x plus 1. So again, I'm in a situation where I have to solve for x. So I have to bring everything, all the x's to one side. So if I distribute that t, and then I bring the x's to one side, it's going to look like this. Right? So I distributed the t and then brought the x's to one side so that I could factor out that 5 to the 2x. All right, do you see how it's flowing very much like 35? So far, so good. Okay, all right. Ln of both sides again, no surprises. This is a complicated question. You can drop down the 2x. Over the ln of 5, and then divide by by 2. So you're going to get 1/2 the ln of t plus 1 over 1 minus t over ln 5. And that's your final messy answer. Oh, yeah, a log is fine. You could do log. Totally fine to do log. You get, it would be the yep. Log will work too. For number 15 on that solvent worksheet, we kicked that out. That's not on. I believe, let me double check to see what that dealt with, but I think that was, I think we took out 15. Okay, should be viewable now. Yes, you don't have to know that. You got it, Tareem. Yeah, 15's out. Okay, Reem, you want page 332.98. Okay, I'm right there. Let me do that for you, Reem. 332.98. I got the half by dividing by 2. Sure. Yep, 65, 66, 72. 65, 66, 72. Okay, so Reem, for this one here, it's the same strategy. You want to get rid of that negative exponent. So you multiply across by x to the 0.3. Oof. Sure thing, Ali. Wow. To remember. Okay, this becomes 8x to the 0.6 minus 8 is 63x to the 0.3. Okay, Reem, you see this here? So this ends up being x to the 0.3 squared. You set up yourself up with another quadratic. Yeah, sure. Reem, you with me so far? I think I factored that correctly. So here you get t equals, for 98, since you were asking 98, you get t is negative 1 over 8 and t is 8. So it's not a t though, it's an x to the 0.3 is this, or x to the 0.3 is 8. Not, you don't like it though. You don't like this solution. It's a little bit messy. Then you have to solve for x. So therefore that means that this is really x to the power of 3 over 10 is negative 1 over 8. So that means x is going to be negative 1 over 8 to the 10/3 is one answer. And this is, like I said, x to the 3 over 10 is 8. So this is x is 8 to the 10/3. So those are your two answers for 98. Those are the two answers for 98. Okay, several people wanted 99, so I'll take care of 99 right now, since that was asked a couple times. So if you're looking at 99, you know that 2 log base 3 of x minus 2y is equal to log 3x plus log 3y plus log 3y. They want you to find x over y. I'd imagine with this one we have to use our logarithm properties. So right away, I want to use my logarithm properties to kind of put this all together. So starting us off right away, I'm going to go like this. right? Like I can pop the exponent back to the top on the left-hand side, then use my logarithm properties to put them together through multiplication. And then I want to get rid of these logs, which you can just drop the log directly, but I don't want to confuse you. So let's bring it to one side. Okay, let's use our log properties to simplify this. So I can bring this all to one side. Then this becomes log base 3 of x minus 2y squared over xy is 0. Right, then I go right to exponential form over xy. Okay, so 5.7. One and 4. X over y. All right, are you guys with me so far with this 99? I'm just trying to see where everyone's at. All right. Is 99 good so far? Okay. Oh, sorry. I wasn't sure. Okay, so what I did was I expand out the right hand side to get x squared minus 4xy plus 4y squared. I just brought everything to one side. You get x squared minus, what is this, 5xy plus 4y squared. This factors into x minus 4y times x minus y. Do you see that? Like you can factor this. I don't hope it's not confusing you guys, but this factors into this. So therefore, either x minus 4y is 0, or x minus y is 0. So that means that either x equals 4y, or x over y is 4, or x equals y, or x over y is 1. So the answers are 1 and 4. For that one. That's 99. Interesting. Interesting question. Oh, okay, sure. If I gave you x squared minus 5x plus 4, you agree it factors into x minus 4 times x minus 1, I assume? So the only thing you do is you tack on a y at the end, because it was a y squared and an xy. Well, you can't Gioth because they asked you what x over y is equal to. Like they act in the question for 99, they asked for the ratio of x over y, so they want you to kind of, like you notice here I had to divide across by y to get 4 and divide across by x to get 1. Okay, good. Good. Okay, kind of tricky question. Okay. So there's number 99. And then I've got what else is on here? All right, let's check some of these off. 99's done. I did 98. Okay, let's get to 332. I'm right on 332. There's a bunch of them 332 here. So 66, 65, 66, 72, I can go through all those. And then I'll get to 101 as well. I'll just start to go through those. So 65 is log of x squared, is in brackets log of x all squared. So for this one here, for 65, the idea here with number 65 is you want to bring, like we've done this several times, but the idea is on the left hand side you can drop the 2, and on the right hand side you cannot. So then you just bring everything to one side when you see this, right? You bring everything to one side and then factor out the log of x. So I can factor out the log of x, and I'm left with 2 minus log of x is 0. This is all right so far. Let me know if this is okay. So you have two options. Either log of x is 0, or 2 minus log of x is 0. Right, those are the two options. Either log of x is 0 or 2 minus log of x is 0. So then you go to exponential. That means either x is 1 or log of x is 2. Okay, sorry, 1 second, Dream. Or x equals, in this case, 100. So the answers here are 100 or 1 for 66. The left side, right side check for 65. If you did a left side, right side check for 65, you would just sub it in. Oops. and see, like, here, just to show you, if you did want to check your answer, like on tomorrow's test, what you do is you could do left side and right side, and then let x be 1. This will be log of 1 squared is the log of 1, and that means that's 0 on the left side. On the right side, it's going to be log of 1 quantity squared, and the log of 1 is 0, which is 0 squared, which is 0. So you can kind of do a left side, right side check by doing that. So I know that like 1 is good. And then you know doing a similar thing with 100, you get the same answer. Number 66 is the same idea. If you're looking at 66, it's the same idea. This will end up being okay, I'm still here. This will end up being t squared minus 2t equals 3. Or you get t minus 1 times t plus 1 is 0. For 66. Yep. Yeah, very good, Gaff. Yep. Is 66 okay? So like I was saying, I let t equal log base 3 of x, right? Because it looks just like a quadratic. For sure, Tareem. I brought everything to one side, factored it, and set them equal, and then solved. I'll try to get 61. 61 and 69. Okay. Log base 4th root of x. So see, with 61, and please let me know, I'm going to move on to Katrine's question for 61, but let me know about 66 if you need any help who had asked it. But for 61 here, this is x to the 4th over log of x, the whole thing to the half. So once again, they're just testing you on if you know when you can drop and when you can't. You can drop the quarter on the left-hand side. So that's what they're getting at here. So I can drop the quarter on the left-hand side. And I can't do that on the right-hand side. So then again, we bring everything to one side. just as we've done before. And again, we factor out the log of x to the half. Right, so just very similar to like what we've been doing, same strategy. And then you're going to set either this thing is 0 or this thing is 0. Those are the only two options. So option 1, you're going to have log of x to the half is 0. And option 2, log of x to the half must equal 1 for that to be 0. I factored it out I factored a log x to the power of a half. So this is really to the power of 1, and this is, as you know, is to the power of a half. So if I'm factoring out a log x to the half, this becomes, 1 minus a half is a half, and then a half minus a half is just 1. So like you just have that. Yeah, I disregarded the quarter because Yusria, if I put the quarter down, let's say I kept the quarter with it, you can, but then you just multiply across by 4 and it doesn't matter. You're back to this idea. So then I need to solve these. Now I have to solve this thing, so I have to square both sides. I'll do it, well, you do the same thing on both sides. So if I square the left hand side, becomes log of x is 0, which means 10 to the 0 is x, or x is 1. And square both sides here, you get log of x is 1, which means 10 to the 1 is 0, or x is 10. So the answers to this are either 1 or 10. Right, Tareem, did I answer your question? Because I know you had asked it. Okay, I want to get back to some of Ali's questions. Ali, are you still there? I'll wait for your response. I'll move on to Tareem. I know Tareem's here, so I'll look at 69 that Tareem had asked, but I want to make sure I get to your questions on page 350 as well. So, yeah, no problem, Tareem. I'll answer your number 69 now and wait for Ali if he's still there. I can help him with the ones, and Reem as well. Ali and Reem. Okay, 69 here. I did not factor out a quarter. The quarter came about from dropping the fourth to the front right here. I had dropped the fourth down to the front, and I got that quarter. Okay. Okay. Someone had asked 49. I think it was Ali. But I'll go ahead and answer. It's log of x equals ln of x. Like, when does the log of x equal the ln of x? So if you're answering number 49 here and you want to solve for this, you just what's the best way? I would probably just do a change of base for number 49. Right, so if you're looking at 49 here, I would just change the base. So this reads log base 10 of x is ln of x. I would change this to log base e of x is log base e of 10. So this is just ln of x over ln of 10 equals ln of x. I think that's probably the easiest way. So right, so just bring everything to one side. Like, so I did a change of base, log of x, change of base, brought everything to one side, factor out the ln of x, and then I guess I could clean this up. Maybe you don't have to do that. Maybe there's a simpler way with this one. Yeah, the only way this is going to be 0 is if the ln of x is 0, which means that log base e of x is 0, so e to the 0. So the answer to this is just 1. But it kind of makes sense because if you look at this graphically, you're asking, when does log base x intersect with ln base x? It's going to kind of look like something like this, right? They're two ln functions, so the only spot that they would cross is at 1. Two log functions, I should say. One has a base of 2.71 and the other is a base of 10. So there's 49. If Ali's out there, I've answered your 49. Reem, you had asked 51, so I'll take a look at 51 for you. Please let me know if there's any questions with 49. Okay, so for 51 here, Reem was asking how to know the other side could not be 1. For 49, the other side could not be 1. Well, for 49, I brought everything to one side. I factored out the ln of x. The only way, like, this is just a number, so it's never going to be 0. The only way this can be 0 is if ln of x is 0. So that means ln of x had to be 0, which means x had to be... Oh, this is just a number. So 1 minus ln of 10 over ln of 10 is just like some number. It's just a constant term, right? There's no variable attached there. So it had to be... The only way for that to work was ln of x had to be 0. Okay, Reem, for 51 here, you're going to graph the absolute value of e to the x minus 4. So the idea here is you have to know what your parent function looks like. So e to the x is your just a growth function. That's e to the x. If you do e to the x minus 4, this has a horizontal asymptote at 0. Now you're taking a horizontal asymptote here at y equals to 4, right? So to graph e to the x minus 4 first would be the thing is to graph that first is it's going to go down, and if I were to graph this, now it's gonna, the same idea, so what I have here in black represents e to the x, what I have in orange represents e to the x minus 4, and then what I have in green is going to represent the absolute value, because what happens is everything below gets reflected back up. So this will end up reflecting up like this and tend towards that way. So what I have in green here is the absolute value of e to the x minus 4. So you have your e to the x, then you have it shifted 4 units down, then everything below, which is everything here, gets reflected up to the top, and you've got your absolute value of e to the x minus 4 for 51. Okay, so there's 51. All right, are there any other questions? I've kind of lost track of what needs to be answered or what has been answered. Who's still here to hear some answers? Yeah, the first one was a horizontal asymptote. Yeah, this is y equals negative 4, yeah. Y is 0. Okay, good. Is there anything else I can help you guys with? I wasn't sure. Like I said, I'm not sure who is still online and who still needs my help. 11 and 36, sure. Yeah, Yusria was asking about the... I was assuming Yusria was asking about the one in orange. The 50... The final answer has a horizontal asymptote at positive 4. I thought Yusria was talking about the one I shifted down. Okay. Let me just jot this down. Tareem, 332... 81, 83, 87, 81, 83, 87. Okay, on this page here, someone had said 11 and 36. 11. Okay, and then 36. Is 36 the half-life question? If so, I'm not putting one of those on. But for page 349, number 11, they give you the function 3 times 1 minus e to the negative x. Okay, sorry for assigning that. Yeah, I'm not going to put that on. For non-negative values. So the idea with this one is it's just a basic transformation. This is just 3 minus 3 e to the negative x. It's just written a bit. 11 and 52. Okay. It's just written a bit weird so that if you rewrite it now, it's in your transformation form. So this is negative 3 e to the negative x plus 3. And then we can you can graph this. Right, so people usually have trouble, but this is really 1 over e to the x plus 3. So the idea here is, who cares what the base looks like? You know that this represents a decay now, right? Like, for example, 2 to the negative x is equal to 1/2 to the x. That represents a decay. And the same thing can be said about 1 over e. That also represents decay. Some of those I did do, but I'll get to Tareen. I'm going to do this one here, and then I'll get to some of Tareen's questions as well. So for this one here, this is just a decay function. Your decay looks like this. So this is 1 over e to the x. And then if you hit this with a minus, if you apply a minus sign to this, and then put a factor of 3 on it, it's going to kind of go something like this. This is kind of like a lazy drawing of this one. And then you're going to shift everything up 3 units. So a quick sketch of this up 3 units looks something like this. Oh, let me check that. I'm getting kind of off. This is 3. Oh, you're right. Yeah, that would be at, oops. That would be there. Yeah, it should. Oh, where would it be? Yeah, it would be up here. Something like that. I can't make it to scale, but yeah. Because if you let x be 0, you get 0, so it crosses through the origin. And it would have that sort of shape to it. All right, 332. What's 52? All right. Let me look at number 52 here. Okay, I don't know if I have the right. Is this the domain question? Yeah, I think I assigned that. Okay, so for this one here, you want to find the domain of this. Essentially, you just want to make sure that the root is greater than or equal to 0, plus you can't be at 0 because then you'd be dividing by 0. So I need 5 to the ln of x minus 6 to be greater than 0. So I essentially want to find where that's at. So if you look at your ln function, it's going to look something like this. And you want to know when is it at 6/5, because you can see your ln function is an increasing function. So as I read it from left to right, it's getting larger and larger and larger and larger. So that means once I find out when it's equal to 6/5, at that value and beyond, the function will be defined. So I'm gonna set this equal to 0 to find when the ln of x is equal to 6/5, right? And then I can, at that value, right? So this will be what? E to the 6/5 is x. E to the 6/5 is x. Right? That's where that would happen at. So the domain of this function is going to be e to the 6/5 to infinity, like open bracket. Because at that value, that's where it's equal to 0, and then after that, you'd have it would be defined. For 52, I don't know if that makes sense for you guys. Is this okay for 52? Okay. Yeah, there's 52. Okay, I'll move on to, I think Tareem has some questions on, is there anything else on this page I can go through? Like while I'm here, I'm on page 350. Is there anything else people need me to go through? Also, I'll move on to back to 332. I set it equal to 0 and solved. I didn't like make up 6/5. I just add 6 and divide by 5. So ln of x is 6/5. You're finding when does the ln of x equal 6/5, then you want everything after that, right? Because you have to make sure that 5 ln of 6 is greater than 0. So I said 5 ln x minus 6 has to be greater than 0. So then I found when it is equal to 0, and then everything after that. Would be good. So then I set it equal to 6/5 and then went to exponential form. And that's it. $37 and 38. Oh yeah, forgetting function. Yeah, I'll quickly run through. You know, to help you out for 37, 38, it's not part of the style of problems that I'm asking tomorrow. Remember, there's only 4 types. I ended up cutting them down, so I mean they're fine to go through, but like I said, it's only one of those 4. So I'll move on to 332. because it's more solving equations and stuff, which you definitely will have. So let's take a look at that. Tareem, are you still there? 332. '81, '83, '87, and then there's a bunch more here. 83, '81, and '87. So 81 here is x to the power of log 10x. X to the power of log 10x is x to the negative 4 over 1,000. So if you want to solve 81 here, this, I feel like this is something like you had in your quiz, sort of. But take log base 10 on both sides. So if I take log base 10 on both sides, I can now drop down that log base 10. So this becomes log base 10 of x squared equals log base 10 of x to the negative 4 minus log base 10 of 1,000. So then you've got your like log of x squared is equal to negative 4 log base 10 of x minus, this is just going to be 3. Right, like evaluating that. So I drop down the exponent, becomes log base 10 of x squared. Use your logarithmic properties, because I was dividing, I changed it to subtraction. And then again, I drop the exponent down. And just like before, you bring everything to one side, you end up getting a quadratic. Right, that factors into t plus 3 times t plus 1 is 0. So you've got two options, either t is negative 1 or t is negative 3. So therefore log base 10 of x is negative 1, or log base 10 of x is minus 3. So 10 to the negative 1 is x, or 10 to the negative 3 is x. So then x is 1 over 10, or x is 1 over 1,000. Is that all right? Dream, is this okay? Yes. Yeah, it's pretty very close to the one on like the quiz, the one that you had asked, 81. Yep. Like I think I asked 86 on the quiz. I had asked 86 on the quiz, and 81 the same, and 80's similar too. Yeah, 80's similar too. So that's 81. 83. And again, anyone else, if you have questions, please let me know. That's 81. 83 is... Oh, okay. So 83 is like an exponential equation question. So you, like looking at it, you want to get a common base for everything. So the common base is 2. So I'm going to change everything to a base of 2. Right, so change everything to a base of 2. And now when you have power to a power, you can multiply. Right, so now a power to power, you multiply. And on the left-hand side, I'm multiplying with the same base. So I can add the exponents. And now the right-hand side is unchanged. Then I can drop that completely. And I'm getting that. Oh, okay, good. Is my screen off? Like, is it in the box, like the final answer? Like, can you see my final answer? I feel like it's getting cut off. Just want to make sure. Okay, good. All right, there's, so negative 8 over 3, that's, and then 83, and then 87. Oh, it gets cut off. Okay. I can, I'll just put my screen up a bit. Let's see. Okay. All right, 87 here is a similar idea. E to the 3x plus 1. E to the 3x plus 1. The whole thing squared over e to the 4th is e to the 10x. So for 87, I mean, it looks kind of messy, but the idea here is you clean it all up. So again, you have power to a power, you multiply. So this becomes e to the 6x plus 2 over e to the 4 is e to the 10x. Dividing with the same base, this becomes e to the 6x minus 2 is e to the 10x. Drop the base, 6x minus 2 is 10x, or negative 2 is 4x, or x is minus a half. Sure, Michael. So there's that one, Tareem. That's minus a half. Page 349, 34. Michael, is that the present value question? Present value? Yeah, you can do it, Wahab. If I did it your way, this be e to the 6x plus 2 is going to be e to the 10x plus 4, and then you'll still get your answer. Sure, yeah. Yeah, let me do the step in between to make sure I didn't lose you. So this is e to the 6x plus 2 is e to the 10x times e to the 4. You get e to the 6x plus 2 is e to the 10x. Let me just put my screen up a bit. Yeah, give me 1 second, Michael. It's 10x plus 4. And then you get the same answer. Same answer as Tareem's version. Okay, Wahab, I'll leave that on the screen there for you. I'll take care of Michael's question. So you're not solving for t for 34, Michael. You're solving for the present value. So essentially what's going on is the person had a child. The child was born. As soon as the child was born, they put $50,000 in an account for their, what is this for? For their education. They let it sit for 18 years, compounded at 8%. Or sorry, they didn't put down $50,000. They ended up with $50,000. So they're essentially asking what amount you have to put down now so that in 18 years, if you have 8% compounded continuously, it'll end up with $50,000. So the following equation is what you're looking to solve for. You're looking to solve for P naught. So P naught, my initial investment, is the 50 grand is what I'm going to end up with divided by this 0.08 times 18. That'll tell me my initial amount. Oh. Page 350. Oh, number 34. Sure, we can do that one. Well, anyways, there's 349.34 has a question. But yeah, we can do page 350. That's my fault. I didn't know there. I just assumed it was that one. 34. So for 34, they want how many years will it take for an investment of $1,000 to double? So there's to double. Obviously, it's going to be equal to $2,000. It's compounded continuously for 34. Oh no, double in interest compounded annually at 13%. So it's compounded annually at 13%. So it's 1 plus just 0.13. And that is to the power of t. Right? Because you're in this question here for 34, it's you're taking you doubled you had $1,000, you want it to be $2,000, and it's 1 plus 0.13 to the power of t. So this becomes 2 is 1.13 to the power of t. Take the log or ln of both sides. It doesn't really matter. T. And this is log of 2 is t log of 1.13. And t is log of 2 over log of 1.13. And I get 5.67 years. Good, good, good. Okay. Again, I've lost track of stuff. Is there anything else I can help you with? Sure. 25, 26. Sure, let me do that waffle first. This was log of 2x plus log a base 6x is 3. So for this one here, normally like it would be the other base, it would be like a base of 2, a base of 4, or 8 or 16 or something that's a power. So here it doesn't really matter. What you can do is just say, okay, the log, like log base 6 of x, just change it to log base 2. So log of the base I want at the top over log of the base I want of the bottom. Right? So you can just like, I wanted a base of 6. I wanted them both to have bases of 2, so I did. So now I can factor out this log base 2 of x, and this becomes 1 plus 1 over log base 2 of 6 is 3. Right? So I just kind of like, the only thing I'm doing here is I'm just getting a common denominator, like putting it all together. And this becomes log base 2 of x is going to equal 3. So it's a little bit messy. I mean, at some point you could get it down to a decimal place. Right? They have this, and then you go to exponential. So it's like 2 to this ugly thing. Does that make sense, Wafa? Like, you just pick one of them and make it the same. Even though it's not like super nice number-wise, you can kind of just force them to both be the same. All right, 332 here. U3 wanted 25, 20. Okay, U3 wanted 25. What did she want? 25, 26. Oh, yeah. I'll outline them for you. Yeah, like 25 and 26 are essentially the same thing. So if I do 25, it's pretty much the same as doing 26. If you look at 25, it's 3 to the x equals 2 times x to the negative 1. You can just take the ln or log of both sides. If I take the ln of both sides, I mean, you can take any base you want of both sides, but then you end up getting this. X ln 3 is x minus 1 ln 2. So then I got x ln 3 is x ln 2 minus ln 2. But I can distribute that into here. And then divide it out. No, I can do those for you. I did one of them, but I can do it. I can see what I did. I don't think I did both of those. 332, 100, and 102. Okay, there's 25, and then I can look at 100 or 102. Sure. Let me look at 101, Ali, because you had asked that a while ago and I haven't gotten to it. So for 101, they let a equal log base 8 of 225, and they let b equal log base 2 of 15. 2 of 15. Express a as a function of b. Okay, so express a as a function of b. Okay, a is equal to log base 8 of 225, which you can see b has a base of 2. Oops, sorry. You can see that b has a base of 2. So then I can do a change of base. So this is log of the base I want of the top divided by log of the base I want of the bottom. Now, 225 is 15 squared over, what is this, 3? Are you okay so far, Ali? See if they're the same. So that means that A is equal to 2/3 B. See? For 101. Okay, so there's 101. Someone had asked, well, I haven't done any questions that you have asked. So let me do 100, for instance. Someone asked 100. I don't know who EY. Oh, Emre. Emre, if you're still there, I can do 100 for you. Log of 3. This is log of 234. 234 is equal to log of 324. Log of 3, log of 2, log of 4, y. Emre, I won't do the whole thing for you. I'll give you the idea so you can kind of see like how it's working. But what do they want you to find? They want you to find the sum. But like, for instance, you know that this is equal to 0, right? They give you like 3 things that are all equal and they set it all equal to 0. So if you put this in exponential form, you know that I can go like this. Right? I take 2, raise it to the power of 0. It's equal to this. Then do it again. So 3 to the power of 1 is equal to log base 4 of x. So therefore x is 4 to the power of 3. So like, I know that x is equal to 4 to the power of 3. And if you take 4 to the power of 3, you get 64. Oops. And you get 64 out of that. So you know, like, if you do it again, you'll find y. And you do it again, you'll find z. You know what I mean? Like, if you do it all those times, you'll find y and z. So like, I kind of I set the first one equal to 0 and then unraveled it. I got x. If you do it again with the next one and the next one, you'll find y and z. And then you can, they ask for the sum, but really you're finding x, y, and z. Okay, is this good? You're welcome. You're welcome. Okay, guys, that's about it for me. That's like an hour and a half or so. I think an hour and 40 minutes. Use 3 of the. You just take the ln of both sides. It's the same as, exactly the same as 25. Take the ln of both sides and solve for 26. I can do. Sure. Log base 2 of... Okay, fine. Okay, a couple more. Log base 2 of... Yes, I'm aware of. Log base 2 of 3x minus 2, 3x plus 2, minus log base 4 of x is 3. So I'll do these two, and then we'll have to kind of stop it. So for this one here, what you're going to do is get yourself a common base. So change that base to base of 2. So log of the base I want of the top over log of the base I want of the bottom is 3. So you just do a change of base. This becomes 3x plus 2 minus log of 2 to the x over 2 is 3. And right here, I would probably multiply across by 2 as my initial first step, as I would multiply across by 2. Then I would pop that 2 to the numerator, to the exponent here. And then I'd go right to like this step where I can pop that to the top, and then I'm subtracting with now the same bases, change it to division, and then I go right to exponential. So 2 to the 6th is 3x plus 2 squared over x. All right, and then 2 to the 6th is going to be 64. And then you're just kind of solving for x here. So right, so I multiplied across by x, expanded out the right-hand side, brought everything to one side, and then factored this. Does that factor nicely? I bet it does. Or you can just go right to the quadratic equation. I don't really want to, though. Oh, it actually doesn't. It doesn't factor nicely. So you end up getting here x is 52 plus or minus the square root of 2,560 over 18 if you do the quadratic equation. So you can factor out the root of 256 is 16. So this ends up being x is 52 plus or minus 16 root 10 over 18, which is exactly the answer I gave you. It's 26 plus or minus 8 root 10 over 9. I think that was the answer I gave you because I had written down the answers for these. Okay. Do you see that one?